Hey kids, had a question about 1844 on the homework. Thought I'd walk through a video explanation of this. It's a really good question on how to write line notations for galvanic cells. So what we had to do is go back to 38. And for 38, we're going to have to write the line for this galvanic. And it's a little bit ugly because in this case, everything is aqueous. Now, when everything's aqueous, all you have to do is grab one of those platinum electrodes. There are catalogs and catalogs where you can buy different platinum electrodes based on their porosity and their conductivity and everything else. And so we don't care about which one we're going to grab. We're just going to grab some platinum electrode, put that PT on the outside, and then on the left side of this, show the oxidation. We're going from Fe2 plus, comma, to Fe3 plus. Separate that with a salt bridge. Now go from your iodate, IO3 minus, to your I2, still both aqueous. And once again, since those are aqueous, we need a platinum electrode out here. They haven't made any notation here. Did they say sketch the galvanics, assume that everything is standard? If it's standard, we usually leave it alone. But if we wanted to, we could designate that these are 1 molar solutions over here, and these are 1 molar solutions over here. But generally, we don't make note of those unless they're different than a standard. And so that one was kind of tricky because we needed platinum electrodes on both sides. The 38B is a much more straightforward example where we're just showing the oxidation. We're going to take zinc, go to zinc 2 plus, separate that, silver plus, down to silver. And if you notice, the charges are almost always going to go on the inside. Once again, we could make designation that these were 1 molar solutions, but we're not too worried about that. So that's what we did within 38. 42 is a little bit different story because what we need to do is make this cell galvanic. They gave it to us as 2 reduction potentials. So in this case, we're going to have to reverse the bottom one. And so that's going to be H2O2 going to O2 plus 2H plus and a negative 0.68 volts. So we're just going to ignore that that one ever happened. And so if we write the overall reaction for this, we should be looking for something along the lines of H2O2 is, oh my, we need an electrode, don't we? Good heavens. Let's get rid of that. Let's get a platinum electrode out there. So let's put a platinum electrode out there, separating our H2O2. And we've got some H plus floating around out there. Right? And those are both 1 molars as well. Okay? But then we also, it looks like, okay, salt bridge. Yeah. Let's split those up and go to the O2, which is a gas, to the H2O2, to the H plus. And once again, we need a platinum electrode out there. Let me see what we got here. Oh, we don't need that H2O2 out there. We've already taken care of that. So that's just H plus sitting out there on the end. We should not need that H, because our overall reaction should end up being, our overall reaction should end up being H2O2s, and we have 2 of those, plus 2H plus, that's going to cancel out, plus 2 electrons goes to 2H2O plus O2 plus 2H plus 2 electrons. Let's cancel some stuff out here. That goes away, that goes away, that goes away, that goes away. We need H2O2 over on H2O, excuse me, on this side. There we go. And H plus. There are a couple different things we could do with this within the line notation, but that one's pretty sticky. If we had these in any shape or form, this would look pretty good. Not worrying too much about what's going on out here with the H2O and the H plus, just so that we have both of those. That's the important thing. And the good news is that 42B gets much easier for us. We have to flip one of these, and it looks like the more electronegative is going to be the manganese. And so let's reverse that. Becomes a positive 1.18 volts. And so our overall would be Fe3 plus Mn goes to Fe plus Mn2 plus. Now, this is not balanced, and that's okay. We're not worried about it. We just need to see it from the standpoint of the oxidation to the reduction, so that our line notation would be manganese going to manganese 2 plus, salt bridge that, and the reduction of Fe3 plus going to Fe. And look, once again, like we said, the charged species go in the middle. So it goes neutral, up in charge, down in charge. So it kind of makes a little plateau if you think about the charges on those things. I apologize, 42A is a little bit bumpy and kind of ugly, but overall, I think this gets you a little bit closer to where you want to get. I'm Smath. Hope this explanation helped.